This is the screencast for section 3.5, example 4, solving a logarithmic equation, and now this one has 3 different logs in it. Yikes. Well, I don't know how to add two. Wait a second, I do know how to add 2 logs together. I've got a property that says if I have the log, 2 logs of the same base that are being added together, I can combine those into 1 log, so natural log, of the product of their insides. So that would be 3x minus 2 times x minus 1. And that will equal 2 times the natural log of x. Well, I almost have the log of the same base of both sides of my equal sign except for this coefficient of 2 out in the front. So I'm going to change the coefficient of 2 into an exponent. Now I have the natural log of everything on the left equals the natural log of everything on the right. So all this stuff inside the log on the left equals all the stuff on the inside of the log on the right. And now I can multiply out these 2 binomials, set the function equal to 0, and either factor or use quadratic formula to solve. So it turns out that I was able to factor the trinomial made after setting the step after the logs equal to 0, multiplying, combining like terms, and I got x minus 2 times 2x minus 1, which means that x equals 2 and x equals 1/2 are possible solutions. Well, looking back up to the original equation, 3 times 2 is 6 minus 2 is 4. I can take the natural log of 4. And then 2 minus 1 is 1. The natural log of 1, well, that's 0, equals 2 times the natural log of 2. So it looks like that might work out okay. Now, 1/2 causes a problem, though. The natural log of 3 times 1/2, so 3 times 1/2 is 1.5. 1.5 minus 2 is negative. I can't take the logs of negatives. Same thing over here. 1/2 minus 1, that's negative 1/2. I can't take the natural log of negative 1/2. So 1/2 is extraneous. And we caused that extraneous solution to happen when we changed the 2 from a coefficient to an exponent. So unlike the example before, when we couldn't take an exponent and drop it down as a coefficient because it would eliminate an answer, now that we did the reverse, we added an extra answer, an extraneous answer. So x equals 2 is the only solution we have. Then I'll try problem number 35. I'm actually going to do in 2 different ways and check it on my calculator. I'm going to be super thorough. 1/2 times the natural log of x plus 3 minus the natural log of x equals 0. I can combine those into 1 log. I'm going to change the 1/2 to an exponent and combine the 2 logs of the same base using division of their insides. Now, as you can see, what I've done here is I've combined 1 log into 2, and I get the natural log of x plus 3 to the 1/2 all over x equals 0. So a way for me to change this would be saying, I could change this to exponential, so e to the 0 equals, well, that's the square root of x plus 3 over x. So 1 equals the square root of x plus 3 over x, and then I can multiply both sides by x, square both sides, which might cause extraneous solutions. And now I can set that equal to 0 and solve. And I get 1 plus or minus the square root of 13 over 2. Now my other option for this problem would have been to start out by adding natural log of x to both sides. So I could have said that on the left side I have the natural log of x plus 3 to the 1/2, and then on the right, after I add the natural log of x to both sides, I have the natural log of x. Well, now I have the natural log of everything on both sides of the equal sign, so what I'm taking the log of on both sides is equal to each other. So I have x plus 3 to the 1/2, which is really square root of x plus 3, equals x. So here I am down at that step right here. I actually saved myself some work. Either one is going to lead you to the correct answer. It's just a matter of whether you can, I don't know, predict up front which one is going to be more work or less work. So now I'm going to check this on my calculator by putting the left side of the original function in, or the original equation in y1 and the right side in y2. Now since the right side is 0, I don't need to put 0 into y2. I can actually just graph this and do second calc 0 and find it. Now I only see 1 0 here, so I'm going to double check what 1 plus the square root of 13 over 2 is and 1 minus the square root of 13 over 2. Oh, actually, 1 minus the square root of 13 over 2. The square root of 13 is bigger than 1, so if I do 1 minus something bigger than 1, that answer is going to be negative. So I cannot include the negative or the minus portion of that. My only solution here is 1 plus the square root of 13 over 2. 1 minus the square root of 13 over 2 would be extraneous. Good thing I checked that on my calculator. And therefore that answer, I did double check, that is 2.30.